Welcome everybody. This is Unit E, Space Exploration, Chapter 2.2, Technologies for Living in Space. I believe I covered a little bit before, so this will be a part 2, which we're going to undergo hazard environment in space plus a little bit of spacesuit. We need to understand that when it comes to space, we do not have air pressure at all. It's practically vacuum. The reason why in the space is vacuum is you can consider that no atmosphere around us. If you think about Earth has nitrogen as the most, then we have oxygen, carbon dioxide, argon, those kind of other type of chemical that compose the atmospheric area that surround us as a fluid. In space, we don't have any of those particles that vibrate or keep us safe, so it is practically vacuum. And one of the things that astronauts experienced was whatever your liquid component, so that's saliva, blood, tear, and so on, they start boiling. The reason it start boiling is because if you think about liquid can go place to place a little bit randomly, solid cannot move around, but liquid can. If I suddenly get rid of the extra boundary and make it way more, how can I say, space in between, then what's going to happen to those molecules is they're going to be active more, which means they're going to be gasified. They're going to turn into gas. Low pressure does this. So far, we talk about environmental hazard. We talk about temperature in previous lesson, and today we start off with pressure. We also cannot ignore the fact that when it comes to astronaut, they're undergoing a lot of psychological training to not get themselves into a hazard situation that may make them do drastic choices, something like that, which is one of the reasons why being an astronaut is not easy at all. On a long mission, crew members would have to live in a very close quarters like what you see over here. I cannot see a lot, so I'm gonna change it, which is very small area, plus you don't have a lot of mobility in there for months and years. That's a reality of a spacecraft. And when it comes to psychological problem, well, let's think about isolation can cause a lot of psychological problem. Also, when it comes to mobility issue, can also cause psychological problem. And in addition to that, lack of communication. Can also cause psychological problem. So please have that in your mind. Know the fact that when it comes to psychological challenges that astronauts undergo, it is something that is unavoidable. And at the same time, this is one of the reasons why they are having as a crew, not one person, try to minimize the psychological problem as a community. All right, I want you to think about some example of psychological problem and physical problem that crew members can have in a space station after a few months of mission. At this point, teacher can pause the video, let student write for about a minute or so, and after that, please share as a class. The another challenges that people experience is something I like to call microgravity. Gravity, first of all, work like this. Imagine you have one object that has a mass. Also, there is another object that has mass. These two mass doesn't have to be equal to. If you think about our planetary level, let's say the first mass is Earth, second mass is you. We know that Earth mass is way more than the way that you weigh. So that's why we know that gravitational force is always going toward an object that has more mass. However, let's think about the space situation. In space, we are not on a planet. We are actually far away from a planet. Even though there are a lot of other stuff that going around you, you are still far away. Planets, stars, and so on. So that's why the gravitational force that you are accustomed to is going down quite a bit. And we call this microgravity. We are evolved to undergo some kind of change via natural selection by Charles Darwin on Earth, and we adjust to that environment since the dawn of time. However, when it comes to space, we don't have that environment. We are suddenly out of the space for freedom. So let's look at some of the pictures that I put over here. This is what female astronauts undergo. First of all, women suffer less from hearing loss with advancing age and do not display a bias toward loss of hearing in the left ear, which is also possible on Earth and the space. It just aging makes senses go down, or poor senses, if you will. In the space, however, female astronauts do not exhibit clinically significant visual impairment, mainly because the pressure inside of your eyeball gets a little bit less. So that's one. On Earth and space, women demonstrate a slight bias towards accuracy versus speed and responder alertness test. Think about this peripheral vision. When it comes to female, in the space now, female astronauts are more susceptible to orthostatic intolerance. So that means there's a chance of, I don't want to say breast cancer, but there's the milk duct, another duct that is affected in female's breast, and that can cause a problem. Let's look at the space only because of time constraint. You can read the others. Urinary tract. So urinary infection is quite common. One of the main reasons is because the residue of your urea is still stay intacting to female's genitalia. That's one of the reasons. Muscle and bone will lose its contact, and that is one of the most common part. You may even get a little taller in space because you are a little loose. Also, when it comes to human body, we're not designed to be fitted to microgravity situation. Let's look at male body situation. Male body situation, if you look at it, very similar to female, but bone and muscle cartilage will be out of the place. There can be skin burn because everything is stretched. Gonad is susceptible to cancer and genetic germline mutation. Mutation can be done especially if you're exposed to high amount of radiation, by the way. Predominant effect, nausea, vomiting, because your body cannot maintain the food inside of a gastric juice due to gravity, due to lack of gravity in this case. Imagine your stomach is still floating around. We generally have increased cancer risk. I believe I mentioned that when it comes to a female astronaut's breast situation, lump if you will. Cataract can form, impairment of visual ability, neurobehavior decrement, anxiety, fatigue, and performance. And also you can have a little bit of damage in neural sensor, in this case neural stem cells. And circulatory system, it's not going to rotate as efficient as on Earth because of lack of gravity. There can be a little reverse direction of the blood if it's extreme. One of the most common part that we saw was bone problem, muscle problem. Well, let's think about it. If you're weightless, then that's a fancy way of saying we don't need for a strong bone. Think about it. Bones are the one that become dense and dense as time goes so that it can withstand the impact. It can maintain our body just like a pillar or main wood frame of your furniture, pillar of the houses or buildings, if you will. It's like concrete situation. However, if there's a lack of gravity, then we don't need a lot of strong bones. So as time goes, what bone will do is the density will be lost. And muscle will tend to be weakened because remember, muscles are the one that connect bones, fiber to fiber. Muscle fibers are the one that connect. Think about like guitar string, if you will. One thing that you will see is, I want you to look at the density of this healthy individual's bone. It is very compact, and then even though there is a little hole, which is like bone marrow, if you will, we are having it, how can I say, more number with less volume, if you actually happen to count it. On the other hand, if I have less density of the bone, then what's going to happen is we're going to have more holes inside of the bone, and that we call it hollow bone, more hollow in a certain volume of the bone structure, so you will have light bone. Therefore, the effect of weightlessness is being studied aboard the ISS. There are a lot of research happening of how our body can be affected by microgravity, and our technology can somehow mimic Earth, it has to be a capital, Earth environment in a space station or a space suit. That's one of the research that is happening. Other than the medical treatment and so on, we're trying to find some technology that mimics Earth's environment in a space station or a spacesuit so that astronauts do not have to undergo a serious injuries or serious long-term effect due to microgravity. Now at this point, I want you to play What is Microgravity video from YouTube. Right, folks, that was today's class. Your homework is textbook page 417, question 1, all the way to number 8. Exit Lab will be held on Wednesday, which will be about chapter 2.1, 2.2, and probably a bit about 2.3.